This is a walkthrough of the relative advantages of the Strayfield system versus competitors. Let's begin with the typical non-Strayfield electrode system. Such a system employs a variable flapper capacitor for force tuning the frequency of the generator to the oven, reducing the efficiency of the system on the whole. The relatively small plate area of the variable flapper capacitor results in a very slow tuning response to inlet moisture variations, as opposed to Strayfield's significantly larger electrode plates, which are used to tune into the product. It also uses inductors to stub tune the oven, once again sacrificing efficiency in the process. However, one of the biggest drawbacks of such a system is that it uses fixed electrodes, which results in a very high gap between the product and the upper electrode at the dry end of the process. Now notice how the currents are set up in such a system. All the current runs through the frame, and the frame is actually just a riveted structure with high impedance and resulting high RF emissions. Now the system actually consists of rods as electrodes, which results in pockets of very high field density just near the rods. Now when this product starts drying up, the high field density and the very high air gap work in conjunction to create a huge voltage gap between the upper electrode and the product. This is because a higher amount of energy now needs to be passed through the system to couple into the dry product. This high voltage can potentially lead to excessive arcing and catastrophic fires within the product or even in the oven. Now, given the high frame currents and the high RF emissions resulting from these frame currents, this system has physically no chance of complying with the EU legislation for RFI and EMI, that is radio frequency interference and electromagnetic interference. So what chance, if any, does it have of being compliant with CE marking? Now let's compare this with the Strayfield balanced output electrode system. It is the gold standard with a dual-ended output and a moving upper electrode. It moves at about 15 mm per second and allows 20 to 30% variation in power output in less than a second when under load. Now the product is directly used as a tuning piece in this case, eliminating the need for any stub capacitors to reduce voltage in the oven. Now let's move on to see how the currents are set up in the system. You can see the flat plates distribute the RF field uniformly and completely eliminate any localized overheating, resulting in a very high efficiency and throughput. And since the gap between the electrodes and the product is minimal, there is no voltage buildup and the chances of fire or arcing are greatly reduced. Note that the frame currents are really minimal, as all the currents are traveling mainly between the electrodes. Thus, the emissions are extremely low and the system fully complies with the EU standards for radio frequency interference and electromagnetic interference. Now let's dive a little deeper into the Strayfield design, especially with regards to radio frequency interference. Strayfield is the only manufacturer in the world that uses a pi filter in its design, which means that all harmonic frequencies are attenuated at source, allowing only the base oscillating frequency, which is kept well within the ISM band, to pass through. This is crucial especially since the fifth harmonic of such systems falls directly in the airline communication band. Thus, Strayfield is the only manufacturer of RF ovens in the world that has installations right next to airports without any additional shielding to the building. No other manufacturer goes to such lengths to comply with legislation around the world. Others simply take the Volkswagen approach to compliance testing and CE marking. We've already looked at the fire and arcing risk posed by a non-uniform RF field in the oven. Now, in the last slide, let's take a look at how the uniformity of the RF field, or rather the lack of it, affects the product itself. With Strayfield, you have a fairly uniform RF field in the oven, which results in uniform heating and linear temperature buildup in the product. In the competitor system, the product experiences peaks of very high power density, which can damage the product, especially near the dry end of the process, when attempting to achieve the same throughput as an equivalent Strayfield system. We hope this back-to-back comparison of the two systems gives you, the buyer, enough information to make the right choice of RF drying solution for your process. Thank you for watching.